Okay, good evening. Welcome to Math for Kids number 52. Today we're going to have some fun, more fun with continued fractions. Back up just a step so we can see this. But right at the end of yesterday's, that's probably too much, that's all right. Right at the end of yesterday's video, you asked me about a continued fraction for pi. And I just happened to remember that there was not, I don't think there's a neat one for pi, although there may be one that I just don't know. But there is a neat continued fraction for 4 over pi. And it says 4 over pi equals 1 plus 1 over 2 plus 9 over 2 plus 25 over 2 plus 49 over 2 plus 81 over 2 plus ... So this is a neat one. It has a really neat pattern in it. And the question is, can you see the pattern? Well, there's an obvious pattern in it, except for the start. They're all the first number here is all 2s. But the more interesting one is the pattern that goes 1, 9, 25, 49, 81. And we should try to figure out what comes next, because this goes on forever. And if you can figure out what the pattern is, so you must be able to think pi doesn't have a pattern. But pi doesn't have an obvious pattern, but here's an interesting continued fraction for pi that has a really neat pattern, if we could just figure it out. Okay, so 1, 9, 25, 49, 81. Any of those numbers ring a bell? Anything special about those numbers?
They're not Fibonacci numbers.
No? It's not, but funny you should mention that, but that'll come later. Anything else about those numbers? Why don't you factor them? What's 1? You don't have to write anything.
They're all perfect squares.
They're all perfect squares. Poof. Okay, what are they perfect squares of? So we could figure out what one would come next.
This is 1 times 1. This is 3 times 3. This is 5 times 5.
There you go.
This is 7 times 7.
Look at that pattern.
This is 9 times 9.
So what would come next?
11 times 11.
11 times 11, which is 121. And it just keeps going down forever.
Wow.
Wow, that's really neat, isn't it? So there's a neat continued fraction for pi. Okay? And not for pi, for 4 over pi. And if we wanted to, we could start evaluating this, and we would get a good approximation for 4 over pi as a fraction, and then we could flip it over, and that would become maybe it would become a pretty good approximation for pi.
Flip, rat.
So we could do our split, flip, and rat thing. Okay, so that's neat. But anyway, that was just for fun, because you just happened to ask me about a continued fraction for pi. So today, we're going to look at a much simpler continued fraction. And it's this. Are you ready?
Yep.
It's the simplest continued fraction of all. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over ... Okay, do you see the pattern?
Yes. This is all ones.
It's all ones. Anytime there's a number, it's a 1. Okay, so if we went down a million terms, what number would we write?
1. This equals 1.
This equals 1?
There's 1 plus 1 over 1 plus 1 over, and that doesn't equal 1.
It doesn't equal 1, I'll tell you that much. It does not equal 1, but we'll see what it equals. We'll see if we can see a neat pattern in this, because this is a really neat number. And you don't normally think of numbers like this, and you know, nobody studies continued fractions anymore. Isn't that sad?
Yeah.
Yeah, it is sad. Okay, so let's look at some simple examples, and then maybe we'll write them. Let's call this number x. Okay. And then the number that I'll call x1. And we'll just look for patterns. Well, here, I just wanted to write our x's over here, and I gotta make sure they're on camera. I didn't even think about this ahead of time. Okay, x1. Yeah, that's on camera. Great. I gotta scoot back a little bit. But okay, so I'm gonna call x1 this number. Okay?
So this...
What is x1 equal to? 1. Let's draw a little equals there. Okay, so that's that. Okay, now I'm going to call x2 1 plus 1 over 1. Okay, what does that equal? Okay, and just for fun, why don't we make these fractions? So write x1, call it 1 over 1, and call x2 2 over 1.
2 over 1, 1, 1, 1.
2 over 1. Because 2 is the same as 2 over 1, right?
Yeah.
Alright, let's figure out what x3 is. x3 equals 1 plus 1 over 1 plus 1 over 1. Okay? So now we have to, now you're probably not going to be able to figure this one out in your head. So what should we do here first?
Well, it's 2 plus 1, that's 3
Right.
over 1.
How did you figure that out?
It's 1 plus 1 over 1, that's 2.
Ah, okay. You got to go from the bottom, because it's not 1 plus 1 over 1. It's 1 plus 1 over 1 plus 1 over 1, so you got to do the bottom of the fraction first. Okay, so what is the bottom of this fraction?
The bottom of the fraction is 2.
So this is the same as 1 plus 1 over 2.
1 plus a half.
Yeah, what is 1 plus a half?
It's 1 and a half.
Okay, and how do you write 1 and a half as a fraction?
3 halves.
3 halves, okay, very good. So we write x3 is 3 halves. Let's see if we can write this a little better. Why don't we write it this way? This is 1 over 1. This is 2 over 1. And this is 3 over 2. That way just we have a little more room. Okay? Alright?
Good, x3, x3.
Oh, jeepers. 4, 5. Okay, good thing I have you around, because otherwise, after some of these long days of work. Okay, so x4 is going to be 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. Ooh, okay, so how do you evaluate a continued fraction?
You have to go from the bottom up.
Okay, right, you got to go from the bottom up. Okay, so this is 1 plus 1 over 1 plus 1 over what?
That's 2.
Okay, alright, and now we got to evaluate 1 plus 1 over 1 plus a half. What's that?
1 plus a half. It's 1 plus 3 halves.
So on the bottom, it's just 1 plus a half on the bottom. What is 1 plus a half?
Which is 3 halves.
3 halves. So it's 1 plus 1 divided by 3 halves. And what is 1 plus 1 divided by 3 halves?
It's 1 plus 2/3.
2/3, great. And what is 1 plus 2/3?
So I have 5/3.
5/3, awesome. So x4 is 5/3. Now please write your 5 properly and legibly, and then write the 3. Wow, that's one of the best 5s you've ever written. High five. Okay, alright, so you ready for the next one? Alright, so we got an interesting one. 1 over 1, 2 over 1, 3 over 2, 5 over 3. wonder if any sort of pattern is going to emerge here.
I'm just going to leap off the screen.
It may leap off the screen. Let's see. x5. Okay. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. Okay. Did I get 5? 1, 2, 3, 4, 5. Yep. Okay. So how do we evaluate this?
From the bottom up.
Okay. From the bottom up. So let's evaluate this part. 1 plus 1 over 1 is?
That's 2.
Okay. This time I'm just going to evaluate with the eraser. 1 plus a half. Okay. What is 1 plus a half?
3 halves.
3 halves. Awesome. Evaluating with the eraser. What is 1 plus 1 over 3 halves?
It's 1 plus 2/3.
1
5/3.
plus 2/3. Okay, and 1 plus 2/3 is?
5/3.
1 plus 1 over 5/3?
1 plus 3/5.
1 plus 3/5. 1 plus 3/5 is?
It's 8/5.
8/5. 8/5. So x5 is 8/5. Write that down for me, please.
I do see something. 8/5. I see something.
Okay, hold on a second. Let's write your 5 properly, please. 8/5. Okay. Tell me what you see here, because I'm very interested to know.
Well, these are 1 apart. These are 2. These 2 are 2 apart.
Okay.
This one is 3 apart.
Well, let's see. Maybe. It's always good to check for patterns. See anything other patterns you might want to check? Back up just a little bit.
Ooh, I see a nice little pattern.
Oh yeah, you see another pattern? Okay.
This number, this plus this is this.
Okay.
This plus this is this.
Interesting.
This plus this is this.
Interesting. Okay.
So
So you think you might have what for the next one?
13, and then 2 apart. 13 sevenths.
13 sevenths, okay.
Check.
It's an interesting conjecture. So let's write 13 sevenths with a question mark here. That's our conjecture. 13 sevenths. Okay? All right, let's see. It's good to make conjectures. Sometimes they're right, sometimes they're wrong, but either way we're going to learn something. Okay, 1 plus 1 over 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 1. Okay, did I get over, sorry. Did I get 6 ones here? 1, 2, 3, 4, 5, 6. All right, bam, let's go.
Well,
1 plus 1 over 1 is?
It's gonna be 2.
Okay,
I do see something.
1.
Up to here is 8/5.
Oh, interesting. Okay, very good noticing. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. This part we already evaluated. That's 8/5. 1, 2, 3. Yep. So this is the same as 1 plus 1 over 8/5, which is
1 plus 5/8.
5/8, which is
13/8.
13/8, which is exact.
Ah.
Oh, we said 13 sevenths. Oh, shoot, it was 13/8. Okay, well that's fine. We got the 13 right, so that pattern.
I see what a little mistake I made.
That pattern was interesting.
Well,
so 13.
This is 1 apart. This is 2 apart. So this is 2 apart. So this had to be 3 apart. Had to.
It had to be? Okay. Interesting. So why don't you take a look at this and tell me what you think x7 is going to be.
x7, I think, is going to equal. So 8 plus 13 is 21.
Okay.
21. And then this 3 apart. So this is going to be 4 apart. 21. 20.
What? 20 seconds?
Well, this is 1 apart, these are 2 apart, these are 3 apart.
Yeah.
So these are going to be 4 apart.
Okay.
18 plus 4.
Oh.
It's 22.
I don't see any 18s.
Ah, I see. I got confused with this.
Okay.
So this is 12.
12s. Okay, 21 12s. Alright. Let's see.
Got a little confused with that straight sign.
That's straight sign. Okay, so x7 is 1 plus 1 over 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 1. So 1, 2, 3, 4, 5, 6. Oops. Gotta keep going. Plus 1 over 1. But you made the observation that we already calculated this to be 13/8. Okay?
Evaluate with the eraser.
So this is 1 over 13/8.
Which is 8/13.
Right? Which is 1 plus 8/13, which is...
So we have 13/13 plus 8/13. It's going to be 22. 12.
13 plus 8 is...
13 plus 8 is 21.
21/13. 21 12. Oh, rats! Okay? So it went to 21
How do I get that one?
13th. So the bottom goes... Alright, so why don't you look and see if you see any patterns on the top and any patterns on the bottom.
Okay, so these are 0 apart.
Yeah?
These are 1 apart.
Uh-huh.
These are 1 apart. These are 2 apart. These are 3 apart.
Scoot over just a little bit so people can see.
And then these
How
are
far apart are those?
each and 13, they are 5 apart.
Okay.
These are the Fibonacci numbers.
They're the Fibonacci numbers.
Who knew the Fibonacci numbers were hiding in the simplest fraction?
Wait a minute. So look, the numbers on the top are the same as the numbers on the bottom. There's 1, 2, 3, 5, 8, 13, 21. 1, 1, 2, 3, 5, 8, 13. So what's the next one going to be? X8 is going to be what? How are you going to figure out what's on the top?
Well, I know this is going to be 21.
21 on the bottom.
So, 8 plus 13.
What's 8 plus 13?
22.
What?
8 plus 13 is 21.
Okay.
21, that's 1.
Maybe you did something wrong.
I have to do 13 plus 21.
13 plus 21.
34.
34. So the next one we think is going to be 34 over 20. We're not going to calculate this, but you got the Fibonacci numbers.
And then...
This is pretty neat. Okay, so you got the Fibonacci numbers. This fraction, 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 over dot dot dot. Somehow the Fibonacci numbers came out of this.
Wow.
Isn't that amazing?
Yeah, amazing.
Amazing. Amazing. So if you just keep going all the way down on this and evaluate, you keep getting fractions that have Fibonacci numbers in them. That's got to be pretty neat.
Awesome.
I wonder why that's true. We'll talk about that a little bit in the next video, maybe. Okay?
Yeah.
Good job tonight, sweetie.